Okay, for inverse trigonometric functions, I'm going to spend more time in the video than you would normally do just doing the problem because I want to make sure you guys have an understanding of where the values come from. So what we're saying here is what is the angle that when you take the sine of that angle, in other words, the sine of theta, when you take that angle theta, theta equals negative 1/2, or sorry, the sine of angle theta equals negative 1/2. So the question is, what is angle theta? And when we're doing an inverse function, evaluating an inverse, we're evaluating it for its principal solution, which means there's always one answer. To back up a little bit, if we take a trig graph for the sine function, we know that the trig graph is cyclic. So it starts at 0, goes up to 1, through 0, down to negative 1, back up to 0. And that goes from 0 to 2 pi. We can also go in the backwards direction, go to negative 1 and come up. That's negative pi over 2. This would be at positive pi over 2, 3 pi over 2, etc. Now this graph is what defines the domain and range for the inverse function. The domain of the sine curve is all real numbers. The range of the sine curve is from negative 1 to 1. Okay, the range value or the y values. When we talk about an inverse function, which is what we're focusing on with this negative 1, not the reciprocal, but the inverse function is going to switch the domain and the range. So the domain of the inverse function becomes this negative 1 to 1, and the range would be considered the all real numbers that we see horizontally right now. But if the range is all real numbers, then we'd have a graph that goes forever like this, and obviously doesn't pass the vertical line test. So what we do is we restrict the original domain in blue to make sure that we have the original range in red covered, and then we use that when we answer inverse questions. So in order to find the domain of the original function, which is the range of the inverse, we're going to restrict from negative pi over 2 to pi over 2. So when you see this question, sine negative 1 of negative 1/2, the inverse sine of negative 1/2, they're saying what is the angle theta inside this pink box in this restricted domain? What is the angle theta that gives you a negative 1/2? Well, negative 1/2 is going to be right here. And my graph's not drawn completely to scale, but that's the only value. And so when we talk about the inverse sine function, we're only talking about negative pi over 2 to pi over 2. So then I think about, okay, well, sine of what angle just in general gives me 1/2? That's a 30-degree angle, or a pi over 6. And so because I'm between negative pi over 2 and 0, I know that the angle that they're looking for, the theta, is negative pi over 6. You need to know your basic values really well to be able to do this. So for example, you need to know that sine of pi over 6 is equal to 1/2. Same thing as sine of 30 degrees. Sine of pi over 3 is equal to root 3 over 2, okay, or sine of 60 degrees. Sine of pi over 4 is equal to root 2 over 2, or 1 over root 2. That way you can use those as reference angles as we go. So you need to know those for sine, for cosine, for tangent really well. And then you need to pay attention to where this original graph is restricted. So there's a lot of different ways to look at it, but this one drawn inside that pink rectangle is just a very good way to consider the graph. It has to be between negative pi over 2 and pi over 2. So my answer is negative pi over 6.